Hello, everybody. Welcome today. This is Karen Fox. I am with NASA's Office of Communications at NASA headquarters in Washington, D.C. Thank you so much for joining us on in some cases, a pretty short turnaround notice. We have a great panel today to talk about some opportunities with our commercial-public collaboration in terms of some of our spacecraft. I don't want to give anything away. You'll hear from our speakers who will give you more details. We will have each of them give a few minutes introduction, and then we will open up for questions and answers afterwards. The speakers today are Thomas Zurbuchen, the Associate Administrator for NASA's Science Mission Directorate, Jessica Jensen, who is the Vice President of Customer Operations and Integration at SpaceX, Jared Isaacman, Commercial Astronaut and Commander of Polaris Dawn, Patrick Crouse, Hubble Space Telescope Project Manager at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and Kathy Lueders, Associate Administrator for NASA's Space Operations Mission Directorate. With that, I will hand it over to you, Thomas Zurbuchen.
Well, thanks so much, Karen, and thanks to everybody who's taking time tonight on short notice. Before I launch into it, I want to acknowledge the devastation of Hurricane Ian as it continues to batter Florida and is moving off to other populated areas. Our thoughts are with the families of both the NASA workforce and those of our partners who are in Florida, who are, of course, part of our entire Kennedy Space Center community, and really the ride-out team at Kennedy Space Center is really at the top of my mind, and I hope they and residents of Florida, friends of our communities, are safe. It's an amazing time in space. We had this week this first collision experiment between DART with this dimorphous near-Earth object. We have amazing work that's going on around the space station with commercial crew and commercial cargo with our cross-agency partners and commercial partners enabling that. And what I'm going to talk to you about is really, if you want, the consequence of the investments and the work that my good friend Kathy Lueders and her team put into this for many years. And it is about Hubble. To start with, before I launch into really the discussion of what we want to do, I want to just tell you, reassure that Hubble is amazingly successful. It's healthy. It's doing great science as we speak. In fact, we just put a picture out that it took as, in fact, DART impacted into Dimorphos. And it's in its 33rd year, and frankly, Hubble is more exciting than ever because it now is a complementary asset next to the James Webb Space Telescope in a different frequency range, in a different, with a different viewpoint, really complementary going forward. So, but we're here today to talk about the exciting potential for public-private collaboration focused on Hubble. And frankly, a few months ago, SpaceX approached NASA with the idea for a study whether a commercial crew could help reboost our Hubble spacecraft into a higher orbit, one that would extend its observational lifetime and frankly take something off the minds of the AA of science in later decades where kind of end-of-life scenarios need to be considered. Today, we're announcing that we have signed a Space Act agreement with SpaceX to produce a feasibility study of exactly that, as well as some other tools that may be coming to bear, really what the benefits and risks would be to having a private team help support one of NASA's science missions, do so, recognizing the importance of this mission, the risk that comes from it, but also the benefit from that interaction. You'll hear from others today with more details about the arrangement and about Hubble. What I want to provide is a context of why we would sign an agreement like this. Of course, we have a large fleet of spacecraft within NASA's Science Mission Directorate of over 100 missions, 120 and counting, and every one of them is unique with its own goals, its own orbits, its own concerns. And as we go forward and we look at the emerging kind of commercial market, we always want to look at any and all possible opportunities to keep that fleet healthy and accomplish the science goal that NASA has. If private space industry might be able to help us with that, we want to know what the possibilities are, and we want to consider those. Commercial partnerships, we have learned, open the door for new and exciting opportunities for NASA's scientific exploration by offering new ideas and innovative ways to support them. NASA does not benefit from working solely in an echo chamber of ideas, frankly, but benefits from kind of exchanging those ideas openly and actively. It's important that we branch out and find ways to improve what we learn and really add new capabilities to our toolbox of options. I want to be absolutely clear. We're not making an announcement today that we'll go forward with a plan like this. But we want to have a study to see really what would be feasible, future open doors and how NASA can think about supporting our own fleet with Hubble and other missions as we go forward. The data gathered from this study is another tool in humanity's toolbox that we can use to support future science missions and keep Hubble at the forefront of scientific discovery. So Jessica, why don't you go ahead?
Thanks, Thomas. That was great. Yeah, you said it so well, but also from the SpaceX side, we are so proud to be a part of these public-private partnerships that have led to so many amazing things. Yeah, like I said, the DART mission, commercial crew, cargo resupply, all of these have been amazing ways to kind of keep revolutionizing the space industry, and we couldn't be happier to be a part of it. So a little bit more onto the study. Oh, and I will say also, the Hurricanian impacts, we're thinking of all of our friends in Florida, all of our colleagues, just everyone in that state who has been impacted, and hope them all a well recovery after the storm leaves. So first, we're super excited for the opportunity to conduct this feasibility study with NASA. One of our main goals out of the study is going to be to take a closer look at how Dragon can safely rendezvous, dock, boost, and then therefore extend the Hubble Space Telescope operations. We obviously have a lot of experience rendezvous and docking with the International Space Station, so we want to use that as our foundation, but then innovate upon that. Hubble's different. It's in a different orbit, it's a different mass, different vehicle, the detailed proximity operations, that's going to be a little bit different. It'll all be unique to the telescope. And really, we're just looking forward to studying what's possible and what's needed and working all of this in coordination with NASA. Overall, SpaceX and the Polaris program together, what we want to do is expand the boundaries of current technology. We want to show how these commercial partnerships, as well as the public-private partnerships, can creatively solve challenging and complex problems. Missions such as servicing Hubble basically are going to expand our overall space capabilities, and all of this benefits the entire community and helps us achieve our goals of becoming a spacefaring and multiplanetary civilization. So I just want to give a huge thanks to NASA for continuing to partner with us. It's truly an honor. I will turn it over to Jared Isaacman.
And thank you so much, Jessica. I first want to just begin and say what an absolute honor it is to even be on this call today. So over the last few years, what we've witnessed is just an impressive pace of progress across the aerospace industry. Pioneering technology like rapidly reusable rockets has really begun to reduce the cost to orbit to such an extent that commercial space missions are now really possible. And alongside NASA, exploration is one of many objectives for the commercial space industry, and probably one of the greatest exploration assets of all time is the Hubble Space Telescope. So while my comments are a bit specific, please remember, this study has broad applicability. But that stated, with James Webb Telescope now online, Hubble's mission has only gained in importance. So it's absolutely exciting to think about the possibility of extending the life and capabilities of one of our greatest explorers. So Polaris is excited to assist in this study, and hopefully it does lead us down a path that ensures Hubble's ability to continue to serve science for decades into the future. Thank you.
Thank you so much. We will move on to Patrick Crouse.
Hi, thanks for having me on this call as well. I'd like to repeat and emphasize that while Hubble is being discussed as a model in this mission study, this feasibility study, repeat that Hubble is doing great. After more than 32 years, Hubble remains incredibly productive scientifically, with unique capabilities for exploring the universe and the unknowns in the universe. Hubble, using those unique capabilities, working in tandem with James Webb Space Telescope, enables greater productivity than either of the missions alone would have achieved working on their own. As a joint mission with the European Space Agency, Hubble has had more than 1.5 million observations to date and generated more than 19,000 peer-reviewed science papers, so arguably making Hubble arguably one of the most productive scientific instruments in history. In the past year alone, Hubble has released an image of the farthest individual star ever seen. The light of that star left over 12.9 billion years ago to reach us, and has also observed the largest comet nucleus to date, a 4 billion-year-old relic from the early solar system. As Thomas stated earlier, Hubble images of the DART impact into Dimorphos this week, the first ever in-space test of planetary defense. Those images are available today. So even though Hubble has been on orbit for 32 years, its orbit was originally about 380 miles above Earth and has slowly decayed over time due to atmospheric drag to its current orbit of about 335 miles. So Hubble has benefited greatly from the 5 servicing missions that it's had, and it's fitting then that Hubble is used as a model for this study. And we're excited to be looking again at new and innovative ways to keep our mission at the forefront of the scientific discovery. We will ensure that the feasibility study addresses Hubble safety throughout any sort of servicing or boosting scenarios that the study will consider. Thanks to the improvements of those past servicing missions, we expect Hubble will remain operational until the later part of this decade, if not into the next. And again, I'm excited and look forward to the results of the study as the agency explores new possibilities for the future of its science missions.
Thank you so much, Patrick. We will have our final speaker in the panel, Kathy Lueders.
Well, wow, I can't tell you how exciting this is. Here we are getting ready for our Crew 5 mission to the ISS. And yes, I am one of those hunkered down in Florida waiting for Ian to pass. But I'm really struck by, here we are talking about another use for this capability. It's just seen it come to fruition, because when we developed the strategy for Commercial Crew, our goal was to develop a LEO crew capability that also, safely and reliably flies our crews to the ISS. And so we hoped that we could also spur innovation and other LEO uses with this capability. We've seen that so far with Inspiration 4, and now here we are talking about other potential uses. So, I'm really proud of the work and the investment that NASA and our industry partners have made. And I'm still looking forward to continuing to see that being leveraged and expanded on. And finally, I'm going to finish up where Thomas started. I'm one of the lucky ones that still has power and not having flooding. So our hearts really go out to those already impacted by Hurricane Ian. And those, obviously, that may continue to be impacted. It's actually why we do our science and observation that we do, is to hopefully one day continue to find ways to be able to safely notify and help people from these kind of weather events. But I know there's folks out there that are having a really tough time right now. Thank you.
Thank you so much, Kathy. We will move on to questions and answers. Reminder, you press star 1 to get into the queue. And we'll go with our first question, please. Operator, I'll have you introduce them.
Absolutely. Our first question comes from Bill Harwood with CBS News. Go ahead, please. Your line is open.
Hey, thank you very much. I understand this is a study only at this point, but can someone specifically say, maybe Jared, is the ultimate goal to actually use a Polaris Dawn mission to reboost Hubble? And then a very quick one for Patrick Crouse. What's the latest projection for HST's entry, given what we know about the solar cycles at this point anyway? Thanks.
Yeah, so Jared Isaacman here. I guess I can answer the first part of the question. As was stated on the call, I mean, the idea is a study at this point, not just for Hubble, but just broad applicability of these type of potential servicing missions within low Earth orbit. That stated, if the study, takes us down a path where a mission is possible, this would certainly, fit within the, kind of the parameters we established for the Polaris program, and certainly would build upon, the Polaris Dawn mission.
And the second part of that question, this is Patrick Crouse, is that right now, the last projection we had in this past year was that we had a 50% probability of reentry in 2037.
All right, thank you so much. Our next question is from Michael Sheets with CNBC.
Hi, everybody. Just wanted to dive in a little bit deeper there. Obviously, Jared, you guys haven't mentioned a specific stated goal for the second mission of the Polaris program. Do you, in your discussions that you've had with others here, and maybe Dr. Zurbuchen or Kathy can tie in a little bit more here on their side of things, but have you guys talked about the possibility of the second Polaris mission using a Dragon, if this study sees that as being feasible? Maybe you can just walk me through a little of the specifics of where this would fit within what you guys have already outlined on the Polaris side of things. Thanks.
Sure. So Jared Isaacman here again. The Polaris program was all about technology demonstration, either new capabilities that are going to be necessary in furtherance of the objective of making life multiplanetary, or utilizing technology or capabilities that haven't been demonstrated in quite a long time. The Polaris Dawn mission has an EVA, it has an altitude component. These are all things that I think naturally you could build upon and could be applicable to a second Polaris mission that would that could ultimately, should the study go in that direction, be flown. And I'd certainly kick it over to the NASA or SpaceX team if there's anything to add.
From NASA's perspective, here's Thomas. I want to tell you, we did not, in all detail, Jared, you can confirm, talk about what your plans are with every one of those missions. I think we're just looking really at this in this study as what the potential is to really have impact for Hubble or for other space missions that are out there, like Chandra, for example, another really capable mission that has lifetime issues. So no, we did not, from my end, certainly dive into details for what Jared's plans are or SpaceX's plan. Neither do I think that's appropriate. I think it's really what their responsibility is and so forth. It's really focused on this study alone. Kathy may have a different take at it.
Oh, no. I think he covered it well.
Hey, this is Jessica from SpaceX. I can jump in as well. One of the things we look for whenever we're doing new developments are, we're going to do this feasibility study with NASA, with Polaris, and it's, part of it's going to be figuring out the cost and figuring out a little bit of the schedule. What's it going to take to actually make this happen and make it happen safely? Because nobody, we don't want to do something that's going to put Hubble at risk at all. So once we figure out a little bit more on schedule and cost, at that point in time, we could try and figure out what mission we should, if the study shows good, then it's from a cost and schedule perspective, what mission do we assign it to?
Thank you so much. I will move on to the next question, which is Chris Davenport from the Washington Post.
Hi. Hello, everyone. Good afternoon. Thank you. So I'm wondering, is this study simply to look at the technical aspects of how this boost would happen? Or are you also going to look at if there are any legal constraints that you need to work through in order to make it happen? I'm just wondering if there are issues, if you have private citizens and a private company working with really sensitive government property, or is this just like hiring any other contractor to perform a service? Thanks.
Hey, this is Jessica from SpaceX. I think the main goal is going to be technical. So the main goal of the study is going to be a technical feasibility study. From a legal and liability point of view of what you're talking about, SpaceX currently docks Dragon to the International Space Station, which is just an incredible worldwide asset. So I think from a legal perspective, government perspective, we worked these type of things before, and we can get through those things. We may touch on them a little bit in the study, but the main goal of this study is just going to be technical. Is it even technically feasible to do this with a Dragon spacecraft?
I've nothing to add from Thomas.
All right, thank you to you both. Moving on to the next question, which is coming in from Marcia Dunn with the Associated Press.
Yes, hi. Jared, are you volunteering for this mission if it's seen to be feasible, and would you be taking NASA astronauts with you conceivably, and when might that happen?
I think just to reiterate kind of the points that have been made throughout the call, I mean, really, we're just on a study at this point. I'm certainly hopeful that the results of the study support a mission to, extend the life and capabilities of, again, one of the greatest exploration assets, for humankind. So, I think we cross the bridge on who's ultimately, flying it if the study ultimately supports embarking on a mission.
Thank you so much. Next question is from Nell Greenfield-Boyce with NPR.
Hi, thanks for doing this. So how much does this study cost, and who exactly is paying for this study, this feasibility study? And also, I mean, Hubble's been great, but to my knowledge, a repair mission was not the priority, and it sounds like this is something that SpaceX approached NASA about. I mean, I'm just wondering, is there going to be a perception that this is like, to be quite frank, like rich people looking for something to do in space and sort of like settling on Hubble? And, sort of, did you guys have any concerns about how the public would respond to that?
This is Thomas. We think about any and all aspects of work we do. I think if somebody looked at it from the outside and basically should, in fact, as Jared said now a couple of times, right, the study have a positive outcome, I think together we would look even more at what all the elements are for such a decision, including some that were mentioned here. At this moment in time, there's no transfer of funds for this feasibility study. NASA and SpaceX are funding their own participation of it, and I think it's wholly appropriate for us to look at this because of the tremendous value this research asset has for us as well as others that we could consider.
Thank you, Thomas. Our next question is from Alexandra Whitby with Nature magazine.
Hi, thanks, Karen. My question is for the Goddard representative. There have been lots of studies over the years about potentials for robotic servicing, boosting of Hubble. How much, in terms of altitude boost, might this study be looking at for instance, from 335 miles to what? Oh, and is servicing part of the study too?
Right. So what we looked at, we guys think that there's potential cost to reboost from, say, 335 to back to 375, 380 miles. Forgive me, I typically think kilometers. There's up to 600 kilometers. I think that's 375, 380 miles. And then the feasibility study will, in conversations with SpaceX and Polaris, we'll have some conversations about if there's potential enhancement capabilities that we can add on. But we haven't looked at anything specifically at this time.
Enhancement like servicing?
Yes, a potential servicing capability will be part of the feasibility study.
And do you mind if I just add, Pat, if it's okay, do you mind if I add a sentence to that, what you just said?
Sure.
Needless to say, I from a science perspective, consider what we did with shuttle, and servicing Hubble, one of the biggest kind of victories of really the agency as a whole, right? Bringing astronauts to bear and doing these amazing kind of changes of the instruments and all kinds of complexities. I just really want to make sure that everybody understands that as we start this study, I think we're starting at a point that is not at the level of sophistication kind of in our experience base that we were at the end of, the shuttle era. And I think it's just really making sure that we're all just really recognizing that as we look at safety of both assets, that we recognize, kind of that, each step that we, if the study comes out that way, if we decide to go forward, each step will be considered, and then each one of the lessons, even though it was possible in the past, will have to be regained, kind of with new technology, with new partnerships. In other words, don't expect what we did the first time. That is not the right kind of proof point to get started, right? Jared, or Jessica, you may want to add your own comments on this. I just really want to make sure that people, when somebody says servicing, it could mean all kinds of things.
Nothing to add from my end. Thank you.
All right, then. We will move on to the next question, which is from Tim Fernholz with Quartz.
Hello, thank you for taking my question. It's for Kathy. When private astronaut missions go to the ISS, NASA requires them to be accompanied by a former NASA astronaut. So I'm curious, if a mission like this were to go ahead, would you require a employed or former NASA astronaut to participate? And I'm also curious, what would the value of a mission like this be to NASA, and would you be willing to pay for it?
Well, I think the first thing is, when we were talking about the private astronaut missions to the ISS, the reason we're looking at, and we just updated the requirement set, was really to make sure that the operations on the ISS were kind of maintained as seamlessly as possible, really to kind of protect the science aspect of what we need to do on the ISS, and making sure that the people that were going on the private astronaut missions, had somebody that had flown before and been able to help on those missions. Now, that's also, obviously a requirement. We continually look at our requirements, and as we go through and continue to work our private astronaut missions, we'll assess that requirement going forward. But right now, it's the best thing for us to do to keep the very complicated operations on station going as seamlessly as possible while we have, 4 new crew members on board that are fairly new, some of them to the on-orbit environment. I think folks have said probably like 4 or 5 times, we're just beginning the study of this. So I think that, we're kind of just stepping into it, assessing technical feasibility of it. I would say the question you kind of asked at the second part of the question, I think, would be things that we would be fleshing out as things matured. And I don't know, Thomas, if you would want to add anything.
I really don't have anything to add, Kathy. This is Thomas, of course. I think the only thing I want to tell you is that whether we look at investments of any and all assets and kind of any and all capabilities in science, we look at the decadal guidance as a strategy, as one of the key ingredients, how we do that. And so that would be, as we go forward, I want to remind you also that, of course, Roman the Nancy Grace Roman Space Telescope that's launching later this decade is, we have, of course, communicated previously, can be serviced as well. So that capability is definitely something, as an agency, we're interested in the long term, but right now we're doing this study at no exchange of funds.
Thank you so much. We will go to our next question, which is from Jeff Faust with Space News.
Hey, good afternoon. I'm curious, there's this whole emerging industry of in-space servicing, companies developing capabilities to reboost or service spacecraft. Will those capabilities be assessed by NASA at any point in this process before making a decision to proceed with SpaceX for a Dragon mission to Hubble Space Telescope to see if that is in fact the best option to reboost or service Hubble? Thanks.
I think that might be a question for Thomas.
Look, as we get through this study with the boundary conditions that we've now repeated a bunch of times, if we make a next step, we at NASA look at any and all options that are in the interest of the taxpayer, and we should.
Thank you so much. We will move to Kenneth Chang with the New York Times.
Hi, thank you. What's the timeline for completing the study? I want to get some clarification. Who's doing it? Sounds like SpaceX people, but there'll also be NASA people. And notionally, how might this occur? I mean, Dragon does not have a robotic arm.
Hey, this is Jessica from SpaceX. I can answer that. So this is a 6-month study with NASA. So both of us will be, I'd say predominantly on the SpaceX side, we're going to be looking at Dragon capabilities and how they would need to be modified in order to safely rendezvous and dock with Hubble. So yeah, details of exactly physically how that's done and how we also safely do that from a trajectory point of view, that's all to be worked out.
All right, thank you so much. Moving to the next question, Eric Berger with Ars Technica.
Hi, thanks for doing this. 2 questions. I guess one is for Patrick. How much has Hubble's orbit degraded since the 5th servicing mission in 2009? And what do you consider a healthy altitude for observations and longevity? I think you mentioned 600 kilometers, but I wanted to clarify that. And then for Thomas, how many of Hubble's IMUs or gyroscopes are presently operational? Is it 1? Is it 2? I mean, I know that this is just a study, but obviously it would be pretty great if you could replace that. Would that be within the scope of the study, looking at potential options like replacing a gyroscope to add longevity? Thank you.
Patrick, why don't you answer the second question also, Thomas speaking. Go ahead.
I might have to have the second question repeat it to me, but
how many gyros are operational? He asked.
Okay. So Hubble orbit was about between 560 and 565 kilometers at the end of servicing mission 4, and we're now down to just under 535 kilometers. So we've dropped about 30 kilometers since 2009. Right now we have 3 gyros operating. So Hubble had been during servicing mission they had put in 6, 3 of which are what we call enhanced gyros, and it's those 3 enhanced gyros that are still operating, and we expect to operate for quite a while.
And Eric, Thomas speaking here, the parameters of the study certainly would enable the team to look at that as one of the questions to address.
Thank you. Our next question is from Joey Roulette of Reuters.
Thanks for doing this. First question for Dr. Z and Kathy Lueders. Have any other companies or countries pitched this idea to NASA, or was it just SpaceX? And when this study concludes, would you guys consider doing some other kind of program to look at other companies or other capabilities to service or boost Hubble? And then one for Jessica Jensen. What does SpaceX get out of this study? Will this experience, I guess, inform how you guys plan to dock tanker starships in orbit or other things that aren't the ISS? Thanks.
Do you want to take this, the first one?
Well, I think, Thomas, maybe you can talk about the original study. I mean, I think Thomas and I, when people come in with ideas of things that would help us go look and investigate on how to solve maybe potential problems, this is not an unusual thing for us to go do feasibility studies and short-term things to go look at things. This to me is the first outside assessment, but Thomas, you can correct me if I'm wrong.
Yeah, Kathy, first and foremost, we're working on crazy ideas all the time.
Yeah.
And frankly, that's what we're supposed to do. I hope you agree, all of you, that we're always supposed to push the envelope. This is really compelling because, a commercial partner came to us with an idea, and over time, we've had others come with various ideas. This is certainly in the area that we're talking about quite unique and first. So I'm not aware. Remember, I've only been at the agency for the 6 years, and not everybody only talks to me. But I'm not aware of another kind of idea in this kind of comparable to this one, kind of brought to NASA. I also want to just point out that we have tremendous plans with our both commercial partners with our agency assets, and that is with Artemis to go to the moon, right? There's a lot of goals we have that we need to achieve. So kind of for us, the priority certainly with our commercial partners is kind of to enable both kind of commercializing low Earth orbit, but also doing these. So it's certainly not the case that many of us feel that we have kind of a whole new kind of, the way you asked the question, kind of a whole new kind of strategy that we would want to pursue on top of what we're already doing. It's certainly not on my mind at this moment in time, but we should always look at what's out there and explore and see how we can add value to our assets and to our exploration programs.
All right, to extend upon that and answer the second question, what does SpaceX get out of this, Jessica? So first of all, Hubble is a national asset, and it's really an honor for us if we would be able to extend its lifetime. So I think first of all, in the near term, I think that's just a great goal in itself. But SpaceX really sees the future in that we are a spacefaring civilization. And that means that there are spaceships flying all over the place, there's on-orbit refueling, there's vehicles from various companies, there's space stations from various companies. We do things like service very expensive spacecraft in higher orbits. We continue to service telescopes. We build bases on the moon and Mars and do all kinds of things. And so when you look forward to this spacefaring civilization, missions like this where companies are learning to adapt and figure out ways to dock to older vehicles and to, basically make two vehicles in space compatible with each other that weren't initially designed to be that way. I think that's an amazing capability, and that's how the industry needs to move forward.
Thank you. Moving on to our next question, Marina Corin with The Atlantic.
Hi, Marina Corin with The Atlantic. Thomas, you mentioned that SpaceX approached NASA with this idea. Can you tell us who at SpaceX did that? Or Jared, was this your idea? And for Jessica, I know you need to do the study first, but a Hubble boosting mission sounds like something that maybe an uncrewed Dragon spacecraft could potentially do autonomously. So I'm wondering why you'd even need asteroids, too much DART mission coverage. I'm wondering why you'd even need astronauts in this kind of effort, or is this something that you anticipate would require EVAs? Thanks.
Marina, Thomas here.
Or go ahead.
Go ahead,
Thomas.
Go ahead, Jessica. Go ahead, Jess.
I was going to say, again, as part of this study, if there could be something that comes out of the study that says, hey, it does not make sense to have a human mission going to do this. So we're going to look at all the different options. We'll keep, at this point, everything is on the table. That's part of feasibility studies, and that's part of development.
And Marina, I need to probably get back to you because I don't remember exactly what the first discussion was. It's a couple of discussions here and there, in various contexts. I don't really remember who the first one was. I'm sorry. Perhaps somebody else can answer it. It's an idea that was ready to be had. So a number of people started talking. I don't remember exactly who the first one was. I apologize. I'll see whether I can go through my notes and answer it better later, Karen. I just really don't remember at this moment in time. And there's a number of discussions that happened with various people.
Thanks. So, Marina, if I hear more from Thomas, we will get back to you specifically with an answer on that. In that case, let's move on to the next question, who is Stephen Clark with Spaceflight Now.
Thanks for taking my question. I think my questions will be for Patrick Crouse. I know the last shuttle servicing mission attached the soft capture mechanism to Hubble. Would that be something that could enable a Dragon to dock without using a robotic arm to grapple the telescope? Just talk about the importance of adding that to the telescope to make something like this feasible. And if you don't reboost Hubble, when would be the earliest NASA might have to consider doing a deorbit mission or planning a deorbit mission for Hubble? Thanks.
So yes, the inclusion of the soft capture mechanism in Servicing Mission 4 certainly makes a mission like this much more feasible and easier to talk about. And certainly be part of the feasibility study is to see how that adapter is useful and what kind of accommodations may have to be made, since that even that design now is a little bit out of date of what the agency is using for docking mechanisms. But it certainly does provide an opportunity for a direct docking, we believe, without the need of a grapple arm necessarily. What was the second question? Sorry.
It was about when would NASA have to start planning end of mission scenario.
Right, and so NASA is always looking at studies and making plans and considerations. Right now, we're sort of carrying that in the later half of the 2020s. We would have to be having consideration of a mission that would then be ready to launch, say by the end of the decade, to go up and perhaps attach a propulsion system. But that's all notional at this point. There is no official mission that's been designated. The studies continue.
Nothing to add from my end. I just want to say I feel really strongly as to my colleagues here at NASA that really when an asset of the size of Hubble comes to an end, that we think of end of life in a careful fashion and kind of one that considers people on Earth and also the low Earth orbit as a resource. That's it.
Thank you. Moving on, our next question comes from Jim Siegel with NASATech.net.
Hi, everybody, and thank you for taking my question. I think this is a question for Jared, and maybe Jessica will have something to add. I believe my readers are pretty well acquainted with SpaceX, but not necessarily with Polaris. So could you describe for my readers what Polaris does and how SpaceX and Polaris would be complementary in this sort of endeavor? Thank you.
Sure. So Jared here on that. I think where we could be complementary when you think of Polaris and SpaceX to this type of effort is we could be taking advantage of everything that's been developed within the commercial space industry to potentially execute on a mission should the study warrant it, with kind of little or no potential cost to the government, which you would think would be of great benefit to just all of humanity if you can extend the life and capabilities of an asset like Hubble or potentially other assets as more of them are launched in the low Earth orbit. And in terms of just Polaris in general, Polaris was announced earlier this year in February as kind of a partnership with SpaceX to undertake a series of tech development missions. The first of which is Polaris Dawn, which should launch towards the end of the first quarter of next year, and that has a number of components to it that are pretty important for, hopefully enabling and making life multiplanetary. So an EVA, an altitude component, new method of communication. But the idea was, at the time of the announcement, there will be a second mission, of which it's certainly possible the study could result in this type of mission becoming the second Polaris program. And then the third is the first crewed launch of Starship, which certainly would be demonstrating quite a bit of new technology along the way.
And just to add to that from the SpaceX perspective, we've been honored to work with Jared and the Polaris team. Really think Jared pushes us to very creative solutions. And this kind of goes back to the whole point of how people from diverse backgrounds really can come up with the most innovative ideas. And overall, these innovations hopefully push space technology forward. It may push technologies forward that some of us just didn't think about or kind of been stuck in the back of our heads. And now we, have a reason to accelerate and have a reason to do things. All of this hopefully lowers the cost for space travel in the future and just makes the access to space easier for everyone. So I really like the way SpaceX and Polaris work together. I think just benefits the industry all as a whole.
Thank you so much for your answers. Our next question comes from Mike Wall with space.com.
Thank you all. This is probably for Dancer Patrick. Yes, you were saying you were kind of looking for a 30-kilometer boost, like if this does happen. And I'm just wondering what sort of difference would that make to the longevity of HST, and also just in terms of sort of framing this study. It seems like you at first just described it as like a boost feasibility study, but it also seems like servicing is going to be part of it too. So is it safe to characterize this as a feasibility study of like using like a private commercial vehicle to both boost and also service Hubble? Just to get some clarification on that. Thank you.
Right. So the feasibility study, one of the things we'll look at is what is the maximum boost we could achieve. Preliminary assessment has been on the order of 40 to even say 70 kilometers of boost. Certainly, if we were to get back to 600 kilometers, that's essentially the altitude we were at in 1990 when the mission was launched. So you'd add easily 15 to perhaps 20 years of orbit life to the mission if you could achieve that altitude. In terms of the study, yes, we're looking at the idea of the feasibility study would be to look at, again, using commercial technology, commercial partners to both look at it from a boost opportunity, but also feasibility. What kinds of things might you be able to do with the servicing aspect? And as Tom has indicated, we certainly wouldn't anticipate being at the level of complexity of some of the servicing missions that were accomplished, with the shuttle and the NASA astronaut crews from the past. But we certainly are excited to look at what opportunities are available with our commercial partners.
Our next question is from Raman Skiba with Wired Magazine.
Hi, thank you. I think this question is for Jared Isaacman and Thomas Zurbuchen. I just wanted to follow up on some earlier questions since this doesn't really feel like a traditional contractor partnership. I was wondering, if this feasibility study came to fruition, could you give any more detail about how this potential relationship between NASA's space program and Polaris Dawn might work? I mean, for one thing, and Jared Isaacman, no offense to you, but you're, not a scientist or engineer or career astronaut, nor in a leading position at SpaceX or NASA. So, what is your, role there?
Yeah, I think it's a great question. I mean, and really, I would just point you back to the Polaris program and what was announced earlier this year, which is it's a series of tech demonstration missions done in partnership with SpaceX. There are specific objectives that we're trying to achieve with each mission. Certainly, the idea of boosting and servicing Hubble, should the feasibility study support it, would be, a logical second mission. But beyond that, the bigger goal is, helping to deliver on SpaceX's vision to make, life multiplanetary. So, the conclusion of the Polaris program is the first flight of Starship. And that obviously in itself could be a key enabler towards SpaceX's vision. As for my individual involvement, look, I'm just happy to be on the line right now. I think this is incredibly exciting about what this study could ultimately lead to. And if myself and the Polaris program can play a small part in that, it's a pretty good outcome.
This is Thomas. You asked earlier about what contractual vehicles and so forth that we could use. Of course, the answer is, you can guess, right? We have not discussed that because we haven't decided what's coming out of the study. There's a number of vehicles available to us, and needless to say, should we get to the other side of that and need such a vehicle, we'll have a whole set of them available to us. So that has not been discussed, and neither should it have.
Thank you. We do have quite a number of questions left. Unfortunately, we are going to have to end promptly at 5:30, so we'll get through as many as we can, but some of our panelists need to leave promptly at 5:30. Our next question is Leah Crane with New Science.
Hi, thanks for taking my question. I was wondering if this does work out and we are able to boost Hubble, could we just keep doing this forever? Are there other limiting factors beyond needing a boost?
This is Thomas, and of course, I'm going to ask Pat to go right after me. There's multiple things that limit the lifetime of a spacecraft. Sometimes it's propulsion. In this case, it's the orbital altitude, but there's other things that also age over time, such as the gyros, I think we already talked about. So in other words, the devices that keep the spacecraft, the ability of the spacecraft being pointed. There's computers that over time pick up more radiation and therefore become less effective or perhaps have challenges. And the instruments, filters, for example, can get less transparent over time. A whole slew of issues like that are being considered by Pat and his team on a regular basis, and it is true that the orbit is one of them, but it's in no way the only one that relates to the lifetime of Hubble. Pat, go ahead.
Yeah, you said it pretty well there, Thomas. I think as a consumable, right, the orbit is the obvious thing as we're degrading. Hubble, some of the instrument detectors, they get used up just by using them, and so eventually those will become we'll lose the ability to capture significant signal to noise. But the most things that we're focused on right now are the life expectancy of the gyros, life expectancy of fine guidance sensors. We do see wear and tear, so it really is just ongoing aging of the spacecraft components, electrical parts. We have reliability models that we look at, and of course we work, as Thomas said, very hard every day to try to mitigate the aging scenarios with the spacecraft. So we won't last forever, but we're trying to last as long as we can. And as we said, we think we have reasonable expectations of being able to operate productively through the end of this decade and into next decade, we believe.
We are just going to have time for two more questions. Our next one is from Robert Perlman with Collect Space.
Thank you. For Jessica and Jared, can you give a sense of how long this idea has been in the works at SpaceX and Polaris before you approached NASA? And Jared, you mentioned that the Polaris Dawn mission includes some technology demonstrations that might be applicable to a mission like this. Did this idea for a study predate Polaris Dawn and help inform what you would do on that mission, or was it born out of what you're doing on Polaris Dawn?
I'm happy to start that off and then would kick it back to Jessica for anything additional. I would say that when we were giving consideration to what we could accomplish on the first Polaris mission and what that could lead us to for a second mission, the idea of potentially a Hubble servicing mission was one of the ideas up for consideration. So I'd say there's been a lot of thought and energy that has gone into this idea long before, we kind of arrived at this point, just to make sure it was, still in the realm of possible. But considering what we're aiming to accomplish with Polaris Dawn, it does seem like there are things that we can build upon from that mission that would be, applicable to what this study might ultimately determine as appropriate.
Good words, Jared. Nothing to add from me.
Great. And as I said, we just are taking one more question today. For those we didn't get to, please do feel free to contact us and we will try to get your questions answered. Our last question today will be from Manuel Mazzanti with debate.
Thank you so much. I think my question, Jessica answered my question a few minutes ago, so I understand that the study will involve or will take a decision if this needs to be a crewed or an uncrewed mission. But I guess if it's safe to assume that if it ends up to be a crewed mission, some kind of servicing can be done. And I apologize if this was mentioned before.
Yep, I think that's all part of the study. We want to benefit Hubble, and if benefiting Hubble is not just boosting it, but also providing some servicing, and that can be done with the human spaceflight mission, all the better. So it's all on the table right now, and as we get into the study, we'll have to figure out some of these things and see what's possible.
Well, thank you so much. I appreciate everybody coming to this press briefing today. As I said, if we were not able to get to your question, please feel free to contact us directly and we will try to get you an answer. And in the meantime, you can check back at nasa.gov when we'll keep updated as we have updates. Thank you so much to everybody for being here today, and we'll talk soon. Thanks. Goodbye.
Bye, everybody. Thanks so much.